Okay, measures of central tendency. So here we have the mode, the median, the mean. So the mode, always the most, right? The mode is the number that happens the most. The median is always going to be the middle number, and the mean is always going to be our arithmetic average. So it's important to know, this is super important as far as understanding of the bell curve, that the mode, the mean, and the median are all going to be at the same place if it's a standardized set of scores. For instance, here, this is a standardized set. This is a bell curve, right? So the mode, the mean, and the median are all right here in the middle. They're going to always be the same number in a standardized set of scores, always. And this is going to be a positive skew. This is a negative skew, but we'll talk more about those in a minute. So I want to do just a couple quick, well, maybe just one example. Data set, I'm making up these numbers. So let's say our data set has 6, 8, 8, 10, 12, 14. Those are our scores in our data set. So somebody tell me, what is the mode?
It's an 8.
8. And then what is the median?
I feel like that's hard because what is the exact middle? You have 6.
Right, exactly. And I'm glad that you brought that up because that's important to know. If you have a data set where, let's say this is your data set, so you have an odd number, the middle number is always going to be there. But when you have an even data set, you have to figure out what that number is because the middle, there's not a number there, right? So here we have our two middle numbers, 8 and 10. So you add those together and divide by 2. So 18 divided by 2 is, of course, 9. You may not have to, I mean, you can visually look at that and see, I don't like the way that looked. Oops, erase my whole 8. You can visually look at that and see that 9 is obviously the middle number between 8 and 10. So you don't always have to do this equation. You oftentimes look at it in your head and know. But yes, for an even data set, you always will have to add the two middle numbers together and divide by 2. So our median is 9. And then our mean is obviously going to be the sum of ends.
So is it 9.6 for the mean?
Tell me what it was.
9.6.
Okay, awesome. So yes, we just take our numbers. N is the number in your data set, by the way. And so yes, when we're looking at the mean, we just add all of our n's together, so all of the numbers in our data set, and then divide by how many are there. So yes, very good. Wanted to make sure you guys knew how to do the median if it's an even data set. Okay, so mode, mean, median, we got that. Now we're going to move on and talk about the bell curve. So the bell curve, or the normal curve, normal bell curve, any of those, they're all one and the same, is a graph which scores are represented, in which scores are symmetrically distributed around the mean, generally expressed in a z-score with a mean of 0 and a standard deviation of 1. So the standard deviation, I give you the definition there. It's the square root of the squared deviation from the mean. You don't really need to know that because that doesn't really tell you anything. What you need to understand about the standard deviation is that it's the most reliable measure of variability for a sample. And I'm going to show you kind of what I mean here in a minute. And then lastly, as far as the bell curve goes, to remember is this empirical 68, 95, 99.7 rule. These numbers never change, just like your z-scores never change. These percentages never change. So plus or minus 1 standard deviation is always going to be 68%, plus or minus 2 is always going to be 95%, and plus or minus 3 standard deviations is always going to be 99.7%. How, why, I don't know. I don't have those answers, but you don't need to know that. Somebody probably way smarter than I've ever thought about being has figured all this up. But again, you are not going to have to figure up anything. You're not going to have to figure up, you may have to figure up a mean, but that would probably be the most challenging thing you'd have to figure. You're not going to have to figure a standard deviation. So they will generally provide you with the mean and standard deviation unless you're dealing with IQ. If you're dealing with IQ, they're going to expect for you to know the mean and the standard deviation, which we'll talk about here in just a few minutes, hopefully. So I want to look at, this is a picture of the bell curve. Obviously, this right here, for those of you that aren't familiar, this is the sign for mean, this little kind of cursive M thing. And then this is the sign for standard deviation, this little O. It looks like O anyway. So this from here, -1 standard deviation to +1 standard deviation, so all this blue is 68%. And then from -2 to +2 is always going to be 95%. So from here to here. And then 99.7 is always going to be ±3. So obviously that leaves very little out here in these extremes. So most of our scores, almost all of our scores, are going to fit into ±3 standard deviations when we're looking at the normal bell curve. We're going to come back to that. So I'm going to show you how I would draw the bell curve. Now, again, please understand that my way is not necessarily the right way. It's just what I prefer to do and what I feel like works for me. You may choose to have a bell curve that has a lot more on it. You might want to have every single thing. I know some of those pictures, like in Rosenthal, you might want to have all that. Fine, good. If you're able to do that, great. However, I need to keep it simple for me. So if I was going in there and doing this, I'm going to draw my bell curve. I'm going to put in my z-scores. Again, these never change. So 0, 1, 2, 3, -1, -2, -3. Again, those are my z-scores. Those never change. And then the only other thing, which you could do this graphically, but to me, it kind of gets messy. So from here to this -1 to +1 is always going to be 68%. So ±1 standard deviation, plus or minus, my brain got ahead of my hand. ±2 standard deviations is always 95%. And then ±3 deviations is always 97 or 99.7%. So I write that there just so that I'll remember it. If you remember those numbers, you don't even have to write it. Or if you wanted to kind of chart it in here, you could. I could do it because I have different colors, but you're obviously only going to have one thing to write with, so it may be hard. But I could do, yellow is the 68%, and I could do, let's say, green. So from -2 to +2 is going to be this number. And then obviously, but to me, that all looks yucky, and I don't want mine to look yucky and get confused. So I just write them over here. But again, you can label that however makes most sense for you. Okay, so I want to use some application in regards to a bell curve. I'm going to give you a sample question, but again, this is very simple in the terms of if you get a question like this, it's going to have more fluff, but I'm just going to write the simple stuff. So we'll say, Kim took a standardized test with a mean of 80 and standard deviation of 2. She scored an 82. What is her z-score? Okay, and for those of you that know how to do this, great. But give me a minute before you answer, because I'm going to work through it for those that don't know how to do it. So we're going to have 2, 1, -1, -2. Okay. So I need to know the mean is 80 and the standard deviation is 2. So I'm going to go over here, draw my bell curve, put in my z-scores. Again, those never change. And so then the mean was 80 and the standard deviation was 2. So I'm going to write in 80 because remember the mean, the mode, the median are always going to be in the same point in a normal bell curve. That's always going to be the middle. So I'm going to write in 80 down here because that's the middle, right? And then I'm going to move by my standard deviations. So one standard deviation is 2. So I'm going to move by 2, and then I'm going to move by 2 more and by 2 more. Then over here, I'm going to subtract. So I'm going to minus 2 more, and minus 2 more, because 2 is our standard deviation. Does that make sense for everyone so far? And if it doesn't, please let me know.
Yes.
Yes.
She scored an 82. What is her z-score? I'm going to go down here. Maybe I hit the wrong button. I'm going to go down here and find 82. And that has a z-score of 1. So the answer to this question is 1. Does that make sense? Everybody good with that?
Yes.
Okay, so let's say Professor P gave a standardized test to her class. The mean is 60 and the standard deviation is 10. Based on this, I need to have some of these just already ready. Based on this, she knows that 95% scored between blank and blank. So let me give you some choices. Okay, so Professor P gave a standardized test to her class. The mean is 60, standard deviation is 10. Based on this, she knows that 95% of the students scored between, and then I've listed you some choices here. Okay, so let's look at this. The answer for this one is C. But I'm going to show you how to go through it in case you're confused, and then we'll kind of see where everybody is after this one. See if we need to do more or not. I'm not opposed to that at all. Okay, so, oops, I already forgot. Oh, my mean was 60, and my standard deviation was 10. Okay, so I'm always going to draw that in, right? I'm going to put 60 here, then 70, 80, 90. And then over here, 50, 40, 30, right? So what did it ask me? Oh, it says, I know that 95% scored between blank and blank. So this is where you have to use your plus or minus the standard deviations. So 95% we always know is -2 to +2. So we're going to look over here at -2 is 40, +2 is 80. So 95% scored between 40 and 80.